This isn't a painting, it's Jupiter, a massive planet of storms, speed, and strange science most people never learn in school. From its insanely fast spin to the mind-bending forces deep inside, Jupiter is far weirder and far more important to our solar system than you've been told. This is the story of Jupiter the textbooks left out. I am Jay, and you're watching Astrosium. Let's get to our topic. The undisputed king of our solar system, Jupiter. A planet so vast that over 1,300 Earths could comfortably fit inside its swirling embrace. But Jupiter is more than just the biggest planet. It's a world of strange storms, extreme physics, and unanswered questions. Beyond the red spot and swirling gas lies a planet that constantly defies expectations. I'll uncover what textbooks often leave out, from its chaotic atmosphere and bizarre core to its immense magnetic field and 90-plus mysterious moons. Because understanding Jupiter isn't just about one planet, it's about unlocking how entire solar systems are built. So, let's dive in. At first glance, Jupiter is defined by its sheer scale. It is so immense, a true behemoth, that even if you gathered every planet in the solar system, from tiny Mercury to massive Saturn, and packed them inside it, more than half of its vast interior would still remain empty. Yet, despite its colossal size, it is not a world of solid ground. Instead, it is a gas giant, composed primarily of hydrogen and helium, elements so fundamental they are the very building blocks of stars. Indeed, Jupiter is often described as a star that never quite ignited, lacking the mass to spark the nuclear fusion that powers our Sun. This vast gaseous sphere spins with astonishing speed. A single day on Jupiter lasts a mere 10 hours, a dizzying rotation that stretches its vibrant clouds into those familiar, colorful bands we observe. These bands are not static. They are dynamic rivers of gas, flowing in opposite directions, creating incredible turbulence and shaping the most famous storm in our solar system, the Great Red Spot. This colossal hurricane, larger than our entire planet, has raged for centuries, a permanent fixture in Jupiter's southern hemisphere. But even this ancient storm is not immutable. Recent observations from the venerable Hubble Space Telescope, conducted between December 2023 and March 2024, have revealed something truly fascinating. The Great Red Spot is not as stable as we once believed. It is shrinking, a trend observed since the 1930s. But more intriguingly, it's jiggling and changing shape, repeatedly elongating and then contracting. Scientists at NASA Hubble have likened its behavior to that of a stress ball, constantly being squeezed and released by the surrounding atmospheric currents. It's the kind of strange, complex behavior that completely rewrites what we thought we knew. And, honestly, it's the kind of thing I definitely didn't learn about Jupiter in school. This unexpected dance suggests a far more complex and dynamic storm system than we ever understood. And what of those magnificent, swirling clouds themselves? For decades, the conventional wisdom taught us that Jupiter's visible clouds were primarily formed of ammonia ice. But groundbreaking research published in January 2025 has challenged this long-held assumption. These new findings suggest that Jupiter's colorful clouds are, in fact, likely composed of ammonium hydrosulfide mixed with a form of atmospheric smog. This surprising revelation underscores how even the most fundamental assumptions about our cosmic neighbors can be overturned by fresh evidence and collaborative scientific endeavor. If we could plunge beneath those swirling clouds, what would we find? Unlike our rocky Earth, Jupiter offers no solid surface to stand upon. As one descends, the gaseous atmosphere becomes progressively denser, the pressure mounting to unimaginable levels. Eventually, the hydrogen and helium are compressed so intensely that they transform into a bizarre, exotic state of matter: liquid metallic hydrogen. Imagine a substance that behaves like both a liquid and a metal, capable of conducting electricity with incredible efficiency. It is a realm utterly alien to our terrestrial experience. By the way, if you want to learn more about Jupiter, check out this video by my fellow creator Ben on the Shoulder of Science. He's made a video on 10 little-known facts about Jupiter that dives into more things about Jupiter they didn't teach you in school. Now back to the video. For a long time, our models of Jupiter's interior depicted a relatively small, dense, rocky core. But data from NASA's groundbreaking Juno mission has painted a far more intriguing picture. Juno's precise measurements of Jupiter's gravity field strongly suggest that its core is not a compact, solid sphere at all. Instead, it appears to be a much larger, fuzzy, or diluted core, perhaps a mixture of rock, ice, and metallic hydrogen, extending far into the planet's interior. This revolutionary finding challenges our fundamental theories of how gas giants form and evolve. And within these extreme depths, where pressures are millions of times greater than on Earth, scientists ponder the existence of even more exotic phenomena. While more firmly established for ice giants like Uranus and Neptune, the immense forces within Jupiter could theoretically create conditions where carbon atoms are squeezed so tightly they form liquid neon, or even, perhaps, rain down as diamonds. These are not mere flights of fancy, but tantalizing possibilities born from the extraordinary physics at play within the heart of a gas giant. Beyond its own turbulent self, Jupiter presides over a truly immense family. It is the solar system's most prolific parent, boasting a staggering 95 confirmed moons, more than any other planet. While many are familiar with the 4 colossal Galilean moons, Io, Europa, Ganymede, and Callisto, the vast majority are tiny, irregular bodies. These smaller moons are often captured asteroids or the shattered remnants of ancient collisions, each a silent witness to the violent history of the early solar system. Among Jupiter's many moons, one in particular demands its own spotlight: Io. It's a world so extreme, so violently alive, that it deserves more than just a passing mention. I've explored Io's electrifying story in a dedicated video. You can find the link in the pinned comment and video description. Now back to the video, but the true marvel lies in Jupiter's magnetic field itself. It is the largest and most powerful structure in our solar system after the Sun, an invisible shield extending millions of kilometers into space. It is 20 times stronger than Earth's magnetic field. This colossal magnetosphere not only creates those dazzling auroras, but also traps vast amounts of deadly radiation, forming intense radiation belts around the planet. What they didn't teach you in school is that early Jupiter's magnetic field was once 50 times stronger than it is today. This incredible ancient power existed when the planet itself was also twice its current size. This immense, ancient magnetic shield played a crucial role in shaping the early solar system, protecting Jupiter and its inner moons from the harsh solar wind, while simultaneously creating an environment of extreme radiation. Jupiter, with its immense gravitational pull, often acts like a cosmic vacuum cleaner, pulling in or deflecting dangerous comets and asteroids that might otherwise threaten the inner planets, including our own Earth. It has been hailed as our solar system's benevolent protector, a celestial shield guarding us from cosmic impacts. But is this always the case? Does its gravity sometimes inadvertently nudge objects towards us? The answer, like so many things in the cosmos, is complex, and still a subject of ongoing scientific debate. Jupiter's role in shaping the trajectory of countless celestial bodies is undeniable, but the full extent of its influence, both protective and potentially disruptive, remains a profound mystery. And then, there is the most profound question of all. Could life exist within Jupiter's realm? While the gas giant itself, with its crushing pressures and extreme temperatures, is undeniably hostile, its icy moons, particularly Europa and Ganymede, hide vast subsurface oceans of liquid water. These hidden seas, warmed by tidal forces, represent some of the most promising locations in our solar system for the potential existence of extraterrestrial life. The mysteries of Jupiter, from its deep interior to its distant moons, continue to push the boundaries of our understanding of planetary evolution and the very nature of life in the universe. Jupiter isn't just a gas giant, it's a world full of surprises. From its wild storms to its strange core and powerful magnetic field, it's unlike anything else in the solar system. I'm glad I could share a few things we didn't get to learn in school. If you enjoyed this journey, check out more from our What Textbooks Didn't Teach Us About Planets playlist. And don't miss the video from my fellow creator, 10 Crazy Facts You Didn't Know About Jupiter. Link in the description below.